Welcome to the first lecture of direct current circuits. Well, not really. So, what happens is, like the first day of class, I'm supposed to get started on really important material, right? From day one, we gotta cover important material. And then like half my class registers the second day. Yeah, so I don't do that. Instead, I do something else important, though not important enough that it's gonna be on any test, because it won't be. But what I like to do is I like to give students some kind of context as to where they fit in. Right? I mean, like, nobody knows where electricity came from, right? The point of this lecture is to kind of just give you some sense of how old this stuff is. When did it come about? When did humans know about electricity and things like that? Just to give you an idea of where you fit in. And so, don't take this too seriously. You're going to have to answer a few questions after the lecture that count for almost nothing just to make sure you watched it, but we're not going to have tests on this or anything like that. So just sit back and enjoy. Alright, first up, see this picture to the right? Anybody know what that is? Ooh, can't draw there. That is a circuit board. And believe it or not, within 2 years, you're going to know what every single thing on there is. I can point a few out now. Resistors, you're going to know about them next week. We're going to use them all semester. This is an integrated circuit. You're going to use them a bunch in digital circuits next semester. This is a diode. You're going to learn about them in electronics. These big boys up here are called cans. Can, because it kind of looks like a can. Actually, they are capacitors. You're going to learn about them next semester in AC. By the way, be careful. If you're ever like going through a junkyard or dumpster diving, don't ask, maybe sometimes I do that. You need to be careful of these things. They can explode. They can hold electrical charge months, even years, theoretically, forever after they've been disconnected from a circuit. And so believe it or not, people used to get really hurt. Like when they would go look for big old TVs, they used to have those big capacitors in there and they would shock or kill themselves by trying to grab it. So do not touch. Moving on. Oh, look at that. Look at that fancy animation. A brief history of the study of electronics. Alright, so, I always ask my class these questions, and so now I'm asking you. It's not going to work, is it? It's remote. Well, I will try to hear your answers. When do you think one of the first recorded, important word, recorded, means we wrote it down, accounts of experiencing electricity without any knowledge of it? What do you think was one of the first things humans wrote down, experiencing electricity but not knowing what it was? See? I heard your answer. You said lightning, didn't you? I bet you said lightning. You might have said static, but you probably said lightning. Either way, you were wrong. How old do you think this was? How far back are we going? Like 100 years? 200 years? Well, as it turns out, I'll give you a hint. They wrote about thunders of the Nile. So now you have a clue. What could be thunders of the Nile? No, I already told you it's not lightning. What could it be? Turns out it's these guys, right? That weird looking fish thing. 2750 BC. That was a really, really, really long time ago. In ancient Egyptian texts, they wrote about the protectors of all other fish. And in case you haven't figured it out yet, that is an electric eel. Electric eel, catfish, rays are strongly electric. You might be thinking, yeah, strong is a relative word. How bad could it be? They can actually deliver a charge, basically a stun, of 500 volts at 1 amp. Isn't that huge? Oh wait, yeah, you don't know yet. Well, you'll find out later this semester. That's freaking massive. That's huge. To give you an idea, it takes about 1/5 of that to kill you. So yeah, it's pretty strong. Most people don't die though, because it like hits them in the legs. Turns out you don't have many vital organs in your legs. But if we were to put that through your heart, it wouldn't be good. Alright, what about one of the first recorded accounts of someone both experiencing it, okay, so that's just like before, but they were also able to identify it. Ah, now they know it's electricity. When do you think that was? So the last one was 2750 BC. Where are we now? Like if I had to guess, I don't know. I'd probably get, I mean, I know the answer. But if I didn't know the answer and I was in your shoes, I'd have probably said like the 1500s or something. Did you say the 1500s? If so, you're my kind of student. Here's another hint. It's this guy. Now, don't all answer at once. I know our Greek or Roman history classes in high school are so great that you all know the answer. To be honest, I can barely remember his name semester after semester. He is Thales of Miletus. That guy wrote about that in 600 BC. That's what, like 2000, what is this, 2020? I don't know, it was a long time ago, like 2,620 years ago, I guess. Is that my math right? Don't check my math. Alright, he wrote about static electricity. What this guy was smart enough to figure out is if I take a piece of fur and I take something like amber and I rub it together, it creates sparks or attracts other small things. And so that was the first time that we wrote about it and knew that it was a special type of phenomenon. Moving on. Invented the first atomic theory. So, I promised you guys in that intro video that I assume you know absolutely nothing. That you were born yesterday, basically. You can do some basic adding and subtracting, and I'm going to teach you everything else you need to know. But atomic theory is sort of like how do atoms work. And we're going to talk about it, not the next lecture, but the one right after that. It was these attractive fellow. I hate saying this every semester. Leucippus and Democritus. We're just going to assume I'm right in pronouncing that. 460 BC. Now I want you to read this for a second. Think about what they wrote here. I'm not going to say it again. These two guys held everything to be composed of atoms, so everything's made of atoms, which are physically but not geometrically indivisible, that between atoms lies empty space, that atoms are indestructible, have always been and always will be in motion, that there are an infinite number of atoms and kinds of atoms which differ in shape and size. Are they right? Man, you guys are harsh. Yeah, I know they're not perfect, but look at the date. They don't have microscopes. They can't see stuff like that. Look how much they got right. Again, like 2,500 years ago. How the heck did they ever come up with this? What's not right? Well, everything is composed of atoms, which are physically but not geometrically invisible. Well, we can divide them, right? We get a big bang when we do. Between atoms lies empty space. Yeah, pretty much. Atoms are indestructible. Like I said, yeah, we can destruct them. It's pretty powerful. Have always been and always will be in motion. Well, I mean, that's true unless we're at absolute zero, which is the coldest it could possibly ever be, theoretically, which can't really happen. There are an infinite number of atoms. They messed up. Well, actually, I guess there could be an infinite number of atoms. We don't know. We know like 130 or 40, something like that, but maybe we don't know them all. And kinds of atoms, which differ in size and shape. They do differ in size and shape. So, I had a student one semester ask me, how the heck did they know that? And I didn't have the answer. But I did look the answer up. And so, it turns out they figured it out because what else was there to do, right? Like, Netflix wasn't around. These guys had a lot of time to think. Not much else going on. But, when they put their big brains to it, what they realized is if I can take a saw and I can cut a piece of wood in half, that must be made up of particles that can be ripped apart. Same thing if I can put my hand through water, then I must be separating some smaller part to make it happen. And so that's how they came up with it. But they didn't think of atoms like hydrogen and helium and oxygen. They thought atoms like wood atom, bark atom, metal atom, water atom. So that's kind of what they were thinking. Still, really good for 460 BC. Alright, let's get to the modern stuff. First, electrical engineer. Right? So this person is credited with the term electricity. Now we know what it is. We know sort of how it's working. We're writing it down and we're calling it by its name. Electricity. Oh, look at this snazzy dressing. Oh, GQ, here we come. Look at this. This is my friend Gilbert. No, not Gilbert. Yeah, Gilbert, but William Gilbert. He invented something called the versorium, which sounds so much cooler than it really is, but it sounds cool. It's this. Any idea what it does? Nope, not a compass. You said compass, didn't you? It's not a compass. It's pretty close to a compass, though. But compass is not the right answer. It was a device designed to attract static. It could detect static. You can basically use it and focus it on areas of static. Which, I know, it's not that impressive, but it was back then. And so, at this time in the course, I always have you guys build one. And I do it as an experiment to, one, teach you something, because I don't ever do stuff without trying to teach you stuff. But also because I do not like not doing labs. And so it stinks being remote. I found a way to make you do circuits labs. We're going to do them remote. Won't be as cool as it will be once we get back to the lab, but we'll deal with it until we do. The idea here is I want you to design and build a versorium. I give you guys these things: sewing needles, styrofoam cups, aluminum foil, and balloons. And basically I make a competition out of it. I want you guys to build one that on one charge of the balloon, you guys know what the balloon's for, right? We need it static. So you take the balloon and you rub your head. Well, I don't rub my head. I don't have any hair on my head. I guess I could rub my beard, right? Remember the intro video, what I look like? So, yeah. Who can make it go 2 complete revolutions on just one charge of the balloon? That's the goal. And what usually happens is people take like, half of my roll of aluminum to do this. And that's the exact opposite of what you want to do, honestly. When you're doing engineering projects, you always want to keep your goal in mind. The problem with engineers is we think that engineering is just cool. We like building stuff, right? That's what makes us want to be engineers. And so we want to build the biggest, coolest, baddest device we can. But in the real world, that's not what you want to do. You want to build the device that is best at solving your problem. And so the best design for this thing is a really, really tiny one, right? Because the goal is to make it go around twice. What stops it from being able to revolve around? Friction, right? And what makes friction worse? Gravity. Well, we can't really turn off gravity, right? That's not going to work. But also the amount of area that touches, right? If I have more surface area touching the ground, it's going to make it harder to turn. And so the best design is usually the one who builds the smallest one that is still big enough to detect the charge. So I apologize you didn't get to partake in this great experiment. The other thing I do is I make sure we all pop the balloons when we're done at the exact same time to annoy our neighbors. But you can do that in your own apartment if you want. I won't stop you. Alright, now we're into the seriously modern stuff. Alessandro Volta. Remember that name, right? We're going to do something with that name a little bit later. This guy was born 1745, died in 1827, and now we're designing real life stuff. So those of you who said 200 years ago, I mean, that's when this stuff really got kicked off. He invented, or we think he invented, the first battery. I'll come back to that in just a minute. This is it. You can actually still see it in the British Museum or the London Science Museum or one of those museums over there. I saw it once. If you want to hear something that's going to make you angry, because I know your cell phone battery is probably about to die, this battery still works today. It doesn't get recharged. It's just still working. I mean, it doesn't have a lot of charge left, but it's still going. Basically, the potential difference of electric energy, which we will talk about later, voltage, is named after him. And I say we think he did it because actually in modern day Iraq, we found this jar. And this jar had remnants of acid in it. And it also had 2 different types of metal in it. And as you guys will know, a week and a half from now, that is literally all you need to build a battery. And so it may not have been a battery, but what the heck else were they doing with a jar full of acid and 2 metals? I don't know. I'm not a historian. But anyway, that could have been it. It's called the Baghdad battery. Look it up. It's interesting. All right. Oh, gosh. André Marie Ampère. I hope I pronounced that right. This guy here basically was one of the founders of electromagnetic theory. Turns out, if you take a coil and you spin a magnet around it, electricity happens. We're going to talk about that too. Not today. And so he invented this. And so ampere, amps, heard of it? 5 amps. That unit of measurement of current was named after him. You're going to know a lot more about it in just a little bit. Oh, I jumped 2. Why did it jump 2? Spoiling the surprise. George Simon Ohm. Now we're getting into the stuff that you guys are going to be doing all semester. You have to take this course and do all this work I'm going to make you do because of this guy right here. This whole course is based on his work. Credited with inventing true circuit analysis. What we mean by circuit analysis is analyzing circuits to figure out what they do. He came up with something called Ohm's law. You guys are going to see later on, I make you memorize very little. We got to memorize some prefixes and basically this for the whole term. He found out that voltage basically is related to current and resistance. We named the unit of measurement of resistance, ohm, after him. Michael Faraday. Now, to give you how important this guy was, Einstein. You've heard of Einstein, right? Older guy, great hair, that guy. So he had 2 posters on his walls of famous engineers. One of them was this guy. Imagine Einstein having your poster on the wall. You gotta be somebody big, right? He's the guy who discovered if you take a magnetic field and you move it around a wire, current will flow through it. This is why we have electricity in our homes today, people. This is important stuff. It's why you have speakers. It's why you can hear me right now. And the reason I like to point him out, this guy knew almost no high-level math at all. He was not a math genius. Lots of times people come to me and say, you got to be a math genius to be an engineer. I'm like, nope. Talk about Faraday. So he basically knew basic math and no high-level stuff. But he was considered one of the best experimentalists in history, meaning he played with it. He did the practical. He built stuff. And so, we wouldn't have a lot of the stuff we have today if it weren't for people like Faraday. Both sides are important. That's why I'm so proud of the degree we created here, is we don't let you only be an expert at math or only be good at building stuff. You got to get both of it in. Unit of capacitance is named after him. The second guy Einstein had on his wall, this guy, Maxwell. You can think of Maxwell as the exact opposite of Faraday. I don't think he could have, fixed his door, maybe. No, I shouldn't be taking shots at Maxwell. I don't know. Maxwell may have been a good carpenter. I don't know. But he was a brilliant mathematician. And so he took all the work that Faraday came up with, and he applied mathematics to it. And this revolutionized the world, because it allowed us to build it at scale and understand it better. And so, quite honestly, we wouldn't have any of the stuff we had today if we didn't have both of these people. That's why both sides are important. He's considered the 3rd most important physicist in history, behind only Newton and Einstein. Alright, my favorite part of the lecture. When I started this job, nobody had any idea who this guy was. Then somebody names a car after him and more people know about him. And Edison, I almost worked for that guy, but I turned it down. Well, not that guy, obviously. The company that guy founded. That guy's been dead. I'm not that old. You think I'm that old, but I'm not that old. The guy died way before I was ever born. But anyway, his company's still around. Ever hear of General Electric? Okay, so, we think politics are bad today. Let's be honest, politics are bad today. They're really bad. But they've been really bad before. They've been bad at other times in history. These two are a pretty good example. Let's talk about them. So, Thomas Alva Edison. He's considered the most prolific inventor in history. I don't know if I'm willing to give him that title. He was a great businessman. Great businessman. I don't know about inventor. So, what did he do? I will not say that he invented the light bulb. I'm going to say improved the light bulb. He did not invent the light bulb. That's what everybody says. Edison invented the light bulb. Edison did not invent the light bulb. He stole it from the wife of, or he stole it from a widow, right? A wife and her husband came up with a light bulb idea. They loved it. He died. She was penniless. Edison basically stole it from her. It's a horrible story. Tinfoil phonograph, steel alkaline battery, motion picture, founded GE. And here's his big failing. He went all in on distributing electricity using direct current circuit. The stuff that we're learning this semester. Turns out DC is useful for all sorts of stuff. In fact, pretty much not every device, I shouldn't say that, right? Because then you guys will think everything. But most of the stuff in your house, like your cell phone, your computer, all that stuff is running on DC. The problem is you can't transmit DC far distances. But, he didn't know about some cost fallacy, and he banked everything on that, and so he was stuck on it. This guy, though, also hired this guy, Nikola Tesla, who came in and fixed all sorts of Edison's problems, and then Edison, being the great businessman he was, refused to pay Tesla, which was pretty sleazy. He told Tesla, "You just don't understand American humor." I don't know what that's supposed to mean, but that's what he told him. Tesla now, he's the exact opposite. Not a business bone in his body, but he's basically the classic crazy genius. Like if you had to build a cartoon character of an insane genius, that's Tesla. He invented all sorts of stuff. The Tesla coil, which, makes cool zaps. Induction motors, which is an important type of motor. Wireless transmission, literally. He was doing radio stuff way back then. Tesla's flying death machine and death ray. I put asterisks next to them because we never really got to see it. He swore he built it or had the designs to build it. We never got to see it. But I'll tell you somebody who does know, the NSA. They know because the precursor to their organization, the moment Tesla died, raided his apartment, took all of his documents, and has never let anybody see them since. So, if any of you end up working for the NSA, I know you're not allowed to tell me, but just tell me that one thing. Did he really have the flying machine or the death ray? Unlike Edison, he went all in on AC current. And it turns out AC is how you actually have to transmit current long distances. The unit of magnetic field is named after him, the farad. Why am I saying the farad? We already did Faraday. The Tesla. The Tesla's named after him. And now a fancy car is named after him. So, as I was saying, politics were bad back then. He had gone all in on that DC, which no matter what could not have worked. The problem is, if we did DC power, like from your wall, in case you don't know, you probably don't know, I'm supposed to teach you, right? The electricity that comes out of your wall socket is AC. And we have to use AC because it's the only way we can transmit at long distances. If we had used DC, you would need a power plant like Turkey Point, you know, the nuclear power plant. Basically, you need one every mile, which would take up a lot of space and just wouldn't work out. Tesla knew this, and so he pushed for AC. And obviously, he eventually won. He basically donated all his patents to another company just to get back at this guy, too. And so to give you an idea how bad politics were, at this time, what Edison did to prove he was right is he went across the entire country putting on big shows where he would execute animals. How horrible is that? Basically, his argument was, AC is way too dangerous. Look, I can kill an elephant with it. And so this is a picture of Topsy. I feel bad for Topsy. Topsy was one of the elephants he electrocuted with AC. And the crazy part is, remember, I told you, Edison invented the movie camera, right? One of the very first movie videos of all times is Edison using his first ever video camera to record him killing poor Topsy. The video's still available on YouTube. I'm not going to show it to you, but it's out there if you actually want to see it. Alright, so we're almost at the end of the lecture. I've sort of given you the big picture of all this. I want to go just real modern times. We got this guy named John Fleming who invented the diode. Diode, super important. You're going to learn about it in electronics in a lot of detail. We're going to use some of them in digital. Then we've got the transistor. And I know I'm going to go off on a tangent, but I got to tell you this story. So, if you ask any electrical engineer who invented the transistor, most are going to say this guy right here, William Shockley. Which is unfortunate, because the way that this worked was this guy was a professor, like me. And these two people were his students. And Shockley was working on some project that these two people thought was kind of boring, right? And so every night when Shockley would go home at, say, I don't know, 5, 6 o'clock at night, these guys had their own project they were working on, this little side hustle thing they wanted that was more interesting to them. And so they worked on it and worked on it. Then one night, Shockley, I guess he left something in the office, maybe he forgot his coat, I don't know, what did people have in the 50s? He went back to his office to get it, and he saw these two guys working on that project. And this man blew up, I tell you. I mean, he threw stuff, he screamed, he fired them both on the spot. That's it, you're out of a job. Get out of here, I don't want to see you ever again. Right? Fair enough, right, man? He's the one paying the bills. If he doesn't want them there, it's fine, I guess. But the problem is, less than 1 week later, this guy filed the patent for the transistor. That side hustle these two were working on, the transistor. They were working on the transistor. He got in, screamed at them, threw them all out, and then filed a patent for it less than a week later. That's pretty messed up, man. You don't get much more messed up than that. Do you feel bad for these two guys? I mean, I did when I first heard the story, because it's a pretty messed up thing. But don't feel too bad for them, because after they left his office, they went and founded a company. I don't know if you guys might have heard of it before. It's called Intel. So yeah, they didn't do too badly for themselves. Alright, 58. Kilby invents the integrated circuit. So remember that circuit board I showed you on the front page of this lecture? It had all those devices on it? Turns out those devices are really big. It'd be tough to fit them in something as small as a cell phone. And so what Kilby said is, hey, instead of putting a bunch of devices and sticking them all together, why don't we just take the silicon and build the devices into a single chip? And that, my friends, is the integrated circuit. 68, Ted Hoff comes along and invents the microprocessor. So why we have computer stuff around us. Basically, it's just a fancy chip that can read instructions and do different things at different times. And so again, this is the end of the lecture. I just wanted to give you some sort of context where you fit in, what basically the role that you're taking after all of this. And as I said in the intro, one of the greatest things about this field is you will understand everything in the world around you, how it all works. If you come up with a great idea, you'll be able to implement it. So, I will see you next lecture for some real stuff. Don't forget that post quiz. It's easy. I promise it's easy. See you soon.